Hi, I'm an old guy and I do maths. Today we're looking at how dimension impacts area in a way, or perhaps ways that initially hard to understand, hard to get one's head around. And what I've got here is four squares drawn on just a plain sheet of paper, 3 by 3, 4 by 4, and 5 by 5. Now, if you say to somebody, um, what what happens if you increase a square from 3 by 3 to 4 by 4? How much more area would that encompass? You get a number of answers, not how much area the new one encompasses, but what is the difference. That's the one that tends to floor people a little bit. And the difference is the difference between 16 and 9, which is 7, which seems not to make very much sense at all. And again, if we expand on this and we move from 4 by 4 to 5 by 5 and get 25, 25, not 29, 25, we see that the difference is 9. So apart from there being some sort of a pattern, if we went from 2 by 2 to 3 by 3, the difference would be a difference between 9 and 4, which is 5. The difference here is 7. The difference here is 9, and so on. Why? It doesn't seem to, if you look at the numbers, it doesn't seem to make any sense. So what I've got here is, and I'll just try and zoom in on this a little bit. Here we go. I've got some graph paper, some quad paper, and here I've got a 3 by 3 square, and it encloses 9 smaller squares. Here's a 4 by 4, 1, 2, 3, 4, 1, 2, 3, 4. It encloses 16. Now, the reason for the difference being 7, you can now see 1, 2, 3, 1, 2, 3, and that one extra, 7. And so for 5 by 5, 1, 2, 3, 4, 1, 2, 3, 4, and this one there makes 9. Okay, so that's the first thing to get one's head around. Now, the other thing that occurs, and can be harder for people to get their heads around, involves this. So I'll just zoom out again, and what I've got is two sets of squares on this sheet of paper. This square is 5 by 5 with an area of 25. And this square here is 10 by 10 with an area of 100. Looking at the ones down here, 3 by 3, which is 9, 9 by 9, which is 81. What is the relationship and why? Well, when I double the side of a square, when I double the sides of a square, what I'm doing is I am quadrupling the area. Why? Because I'm increasing in 2 dimensions. I'm increasing from 5 to 10 in this dimension and 5 to 10 in this dimension. And so I'm not multiplying by 5. I'm not multiplying by, I don't know, think of another number. What I'm doing is I'm multiplying by the difference, the factor of the difference between these two numbers. So the factor from 5, the scale factor, if you will, from 5 to 10 is 2. So I've doubled this, so by 2, 5 by 2 is 10, and the same over here, by 2 is 10. And so the relationship is the square of the factor from 5 to 10, 4. So 100 square units is made up of 4 lots of 25. Now this holds true if we look down here. at 3 by 3, which is 9, and 9 by 9, which is 81. This has been increased by a factor of what? Well, what's the difference here? The difference here is that this has been increased by a factor of 3. And this has been increased by a factor of 3. So, look, 9 times 9, 81. That's the factor. Or 3 times 3 times 3 times 3, if you want to look at it that way. I've spent an enormous amount of time explaining this to people in a sort of an abstract sense. It's much easier if you are able to see it like this, or even better, if you have a large room with square tiles on the floor. It's a great way to learn about the effect of dimension on area, and why it isn't necessarily what it seems. Anyway, thank you for watching. I hope you found this useful, or at least interesting, and if you did, please like and subscribe, and I'll see you next time. Bye.